Good morning, everybody. My name is Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation. And the subject of this week's regular Wednesday webinar is Securing FIWARE Architectures. This is an introductory course on the basic introduction to the security elements which are found within the FIWARE Catalogue. And we will cover basic areas of authentication, authorization, and so on. So the learning goals for this session are as follows. You will learn what are identity management and access control and why you need to use them, and which FIWARE components are available to cover this sort of thing. As is frequently emphasized, FIWARE is a pick and mix bag of components. The only one which you really need is core context, which is the Orion context broker. So if you have alternatives, then that is also fine, but this will cover the ones which are the generic enablers within the FIWARE catalog itself. Then we will describe what authentication and authorization are and how they differ. And depending on your application, you may want to have a system which is purely based on authentication, or you may have more complex security needs, in which case authorization will come in. The usual standard for this sort of thing is these days on the internet is OAuth2, and we will describe various OAuth2 flows and how they are supported. Then getting into the various roles of the various different enablers, we will briefly go into what is a PEP Proxy and what is a policy decision point, a PDP, and covering such other acronyms as RBAC, PBAC, XACML. This will all become clear as the session goes on, so I won't describe what they actually are right now, but let's get on with the show. As usual, the learning materials behind this session are all available online under the step-by-step tutorials repository, and you can download all the materials, run through the examples yourself, see it working in action, so you don't just have to watch, and you can actually be doing things interactively. The usual prerequisites, as shown on the screen. The system is set up using Docker and Docker Compose. You'll need Git to get hold of the initial stuff. And if you're working on Windows, because there are a couple of bash scripts involved, you'll need to get hold of Cygwin. There is a mixture of stuff which is done either programmatically or through direct API calls, or also through, in this case, a GUI, which is available for the identity management section. But if we are sending stuff using API calls, Postman is the preferred tool. Just to recap, today we're doing the section in red on the right, which is where the security enablers tend to congregate. The idea here with the FIWARE catalog is you've got the 5 basic chapters, and we've already covered core context, which is what FIWARE is all about, and how to get some information into your system, which is the IoT, robotics, and third-party systems. However, there is a kind of multi-layer chapter, which is the data API management, publication, and monetization section, which covers both how to sell your data, how to move the context and make money out of it, but also how to secure your data, because obviously security is valid across the every single layer, from processing down to the actual devices themselves. This is where there is a slight difference between the two. Obviously, when you're selling it, you want to be open, therefore that tends to be in green. But obviously, if you're securing, you want to be able to stop people, so that tends to be in red. So that kind of explains what the difference between the two actually is. Let's bring up an identity management tool called Keyrock. Keyrock is an identity manager which holds things like roles and permissions and what have you within a database. As you can see, it's a generic enabler, we are, which depends on a MySQL database. In this particular case, we are running the system not in secure mode. This is simply to make life easier and is certainly not something you want to do in a real life system. So I will be sending stuff using HTTP rather than HTTPS, but obviously you can secure it. You can have an HTTP port, HTTPS port, and within this system there is a default user. Now you can see here that the default user is being set up with the username admin and password of 1234. This again is an insecure way of doing things. So the ideal way to do this is actually to pass all this information using Docker secrets rather than doing it in an open fashion. But this is, as I said, just tutorial material, just making life easy. But beware that you need to think about how security actually works, even in a simple system such as this. So, having run got Keyrock up and running, there is a simple login screen where you can log in as somebody. If I attempt to log in as someone who doesn't exist yet in the system, it will say no. If, however, I go for admin and sign in, it will say you've got an ability to set up various different things. Obviously, if you're using this in a real system, you would tend to delete this initial super user as soon as you've got something worthwhile. The basic idea of Keyrock as an identity manager covers the entities which are shown on the side of the screen. The idea is that your central element here is the application, which is a securable application, a FIWARE application consisting of a series of microservices. This means that the system is implicitly multi-tenant. You can have multiple applications within your system. Now, an application offers a series of roles and permissions. Typically, you would have a role which would be the things you're allowed to do, and then it's a bucket which holds the actual elements which are being checked. So within each application, you will generally have either users, which are just individuals who can do things directly, or organizations, which are groups of users. And in order to reduce the administration burden, there is also a relationship organization role, which would mean that you can offer an administration role to another user who could then just set up people into that particular organization. So if you say, for example, have a management organization, then they would be able to do a series of things, and as people join or leave the organization, you can move people around without always annoying the super user. As I said, you don't have to necessarily use role-based access control, which is RBAC. You could just have users, and you just need to use authentication. However, if you are using role-based access control, you need this role and permission. Now, because we're talking about microservices here, it's not purely humans who are actually interacting with this system. There are other actors, and the two supported other actors within the Keyrock system are a PEP Proxy, which is a policy execution point, and an IoT agent. IoT agent is how to ensure that your devices, your sensors, or what have you, can be able to access a context broker which has been secured. And your PEP Proxy, which is what we'll see later, is a generic middleware for, again, having a gatekeeper between the system and yourself. Keyrock, as I said, offers a GUI-based or indeed API-based interactions for administration. It allows admins to associate users to roles and what have you. And it also offers what's a simple policy decision point. A policy decision point is basically a thumbs up, thumbs down on permit or deny are you able to do this sort of thing? As you can see on the right, you've already seen the basic GUI, which can be reskinned as necessary. You can also send requests, as shown by the curl statement on the right. For those of you who are following here, notice this is a insecure post request because it's sending over HTTP rather than HTTPS. So this is something you would not generally do outside of a tutorial. In this case, you would be sending your username and password in plain text, which is incredibly bad. But as I said, what you would the reason for doing this for a tutorial is that I don't need to bother with getting a certificate, getting through various warnings, say your certificate is self-signed or what have you. If you're going to do this properly. But that's the last time I'll cover this particular warning. So let's log in. Once again, we've got the system running on my local host. I've got Keyrock set up as localhost 3005. And when you log in, you obviously need to send your username and password in the body of the post, which is the standard way you would do it. Again, you'd be doing the same thing as you're doing it with the GUI. As you send this, you would then when you're returned, it says, okay, I'm currently running with basic authorization, and I've not got Authzforce, which is one of these things which will come with later on in the hour, actually running within this system. If you look at the headers, you see there's a X subject token header. This is describing who am I, and therefore whether I can get information back. Now, I'm not sure if this one has been set up or not, so I might need that token itself. But if I try and get the information to the user itself by sending in the token itself, which I've got long things going in there, is that going to run or not? No, that one's not been set up yet. So let's change that. Edit. Variables, auth token. I think I need both of them. Oh, I'll do it this way instead. If I put in a valid token and subject, you can then see that I can actually retrieve back information about myself. I can also do the usual CRUD actions like create users, what have you, add users and what have you. As you'd expect, when you are modifying stuff, it would be patch. When you're removing an organization, it's a delete and what have you. Most people probably wouldn't use the API for this. They're much more likely to want to go in through the GUI because it's a lot easier and simpler to do this. Once again, I can go into this and I can create an application. I can add in information about me or whatever, and various other bits of information which will prove useful later on the system. If you're interested in the API, as you'd expect, there's a Swagger specification for this, but it's again simple CRUD based on the expected verbs. So let's assume that you've got some users into the system based on that authorization we've got beforehand. We're going to need to be able to log in. So I'm going to have to start up my system in a slightly more advanced version of this, where we've got multiple things running. So I'm going to go into the, which one? So having had nothing in our database beforehand, we're going to set it up in a system which has got various users and various people in the system already. I'll just go back to that previous slide where it was saying what the various people in the system actually are. So you've got an application running. Now, if I go back to my system here, we will now have a tutorial application which is running on host 3000. Once again, we are again failing to use HTTPS, but we're going to start with it. Now, what we have here is that we have various different methods we can use. Keyrock as a way to log in. These are all standard OAuth2 flows, OAuth2 being an industry standard for getting hold of authentication. And we can state that within our system, as far as the user is concerned, we need to log in localhost because I'm locally, and but within Docker, you'd have an actual IP address, or you generally have something on the web rather than anything else here. Now we have here a client ID and a secret. These are defined within the application itself when you create the thing to say, okay, this defines my application, and obviously my application itself will have users, roles, permissions, and so on and so forth. So we can eventually log in to the system as necessary. That's the one I wanted. So at the moment, the tutorial application is just periodically being pinged on a health check endpoint. So let's see what it actually shows. I just make sure I've logged out of that one. Because I've set this system up with exceedingly long tokens, because it makes life easier for displaying this sort of thing. Sometimes this doesn't clean out the tokens properly. So if I have a user, I can log in several different ways. We've got this auth code, client credentials, implicit grant, and user credentials. And we'll just show what that means in the thing here. A user credentials grant, this is the typical thing which I showed at the top of the hour. It's basically the username and password. A user wants to log into an application via a client, and the client has got the information and it's completely trusted. So you just fill out your username and password, and it will return something saying, hey, you can get an access token for this. Now, another way of doing things is using the authorization code grant, which is slightly different. It's when you're logging in, but you have some other application which has got your user in it who you also trust. So, for example, if you log in via your GitHub account, you don't have access to all their usernames and passwords. What you do is you say, okay, go over there, log in, and they will give me an access code. And having retrieved an access code, I can then request from that access code more information about the user in question. And it's confirming who the user is from another trusted source. So let's see these two flows in action. If I log in as Bob the manager directly, it says I've got an access token, and it will give me something so I can use this. And as you can see, we're using the user credential grant, and we've retrieved an access token, and we've got this access token. Having done that, we can go back and request more information saying, hey, this is Bob. If I have a look at the code, you can see if we're looking at the, where's the thing gone? Various different grants. This is the user credential grant. It gets the password. It then retrieves the user from the token in question. So it's making two requests. This is obviously the case of get the make sure you know who they are and get the thing, which is what I did with Postman earlier on. I need to log out, and I will just try logging in using the authorization code. When you go for the authorization code, you can see you are automatically pushed to another location. This is the third party which is going to log in for us. And you get an additional sign-in, which is screened from here. As you can see, we've already got this FIWARE tutorial, which is set up in Keyrock, protected by OAuth2. And if I go in as, say, Alice the admin, with a password, and then sign in, it says, okay, we know, I, Keyrock, know who you are, but do you really want to let that application called FIWARE Tutorial to read your public information? Because they are going to find out who you are as well. Now, obviously, I'm going to say yes. And having done that, I get thrown back to the tutorial itself. And you can see, once again, I have got an access token. If you're following on the flow of the code here, is that we have returned to this auth code callback function, which is set up within the identity manager. And then it said, okay, I've got a code. Can I swap this code for a token? And obviously, because it is the you've been granted access, it says, yes, I, Keyrock, have created this code. I know who this user is, and therefore you can actually get the information back. If we log in to Keyrock as Alice, you can see FIWARE Tutorial has been set up as an application, and it has a client ID and secret, which was set up in the Docker parameters in the first place. And also, if we go back to the application, FIWARE Tutorial has got a series of users associated with it as well, so that only those who are allowed into the system are actually authorized to go into the system. There are two other main grants, and of course we can refresh a token because they are generally not long-lived. Yeah, an implicit grant is a system, instead of going through this system of saying, I would like a code, now I would like a token, it's a simplified access which can be done by client-side applications when you've got various restrictions in there. Or indeed, and we will see this later on, you can get applications themselves which wish to say, I would like to be able to access you. This is a good example with the where the application is the one which has got the right to do things rather than the user has got the right to do things. In this case, it's just simply a matter of app request an access token. You can see that the tutorial does support all of these things as necessary. So we now have users in the system, but in order to let users in and do things, we need to start securing our application. Now I'm running that on securing access. Good. Okay. Fine. So let's move on. We can secure the application either directly with our application, or we can actually use a PEP proxy. To begin with, we'll just deal with actually talking between the application itself. So I'll just log out briefly. If I log out, I've got no user in the system. If I just I'll get the log up as well whilst I'm looking at it, which is this one here. If I go to store one, it says access denied. As you can see, what it's actually trying to do here is it's trying to authenticate, in other words, check, is there a user in the system? And then, having been told, no, there isn't a user in the system, it throws me out. If you look at the the code within the security system. For the authenticate, it's purely a matter of have I got a token, have I got a user set up already? There we go. So yeah, all we're doing is we're checking, do we have something in the authorized? And if we don't, and we haven't got a session token, throw me out. So let's log in as a user called Bob. Bob is a manager. Once again, we token, and managers have access to change prices. This is price change area, which is covered by Bob. As you can see, what's happening here is that we are going through a basic policy decision point, which is saying, does this user have the right sort of ability to access things? And that is, where's that down here? Too many functions up here. Price change. Okay, this was in store, so that's a different location. So we are able to, basic policies at decision point. So at this point, what we do is we send a token to Keyrock to say, okay, has this user got the relevant permissions to go through and do something? I'll show you on the postman here, which is securing access. When we are requesting we've got a token of some sort, and we say, for this token, for this particular application, does that token allow you to get on price change, for example? Now, in this particular case, I send it and it says, sorry, that's not a valid token, because that's not the a token which has been created within this system. If I go back again and just take Bob's token, it now says, yes, that's a valid token, and this is the information which you can retrieve from that token. So it says, okay, for this particular case, because we are running in basic mode, we are able to say thumbs up, we are permitting access for that particular user. If I had logged in as some other user who didn't have those rights, then obviously it would not be allowed. If I go back to the Keyrock application, look at my tutorial, I have got various users in here, various groups in here. I wish to manage my roles, and the role of management in turn has got the ability to access price changes. And if I look inside there, this has got a simple CRUD saying this will, for that get on that endpoint, the following users have got a hierarchy of stuff which they can do. So you can see that by linking roles and permissions to applications and users, it is possible to permit or deny various things. Now, this is what's known as role-based access control, and is fine for relatively simple scenarios where you need a bit more than just saying, I have a user. It's more a case of, I have a user and a user can do the following bits and pieces. Now, so far, we've just used applications which are attempting to get hold of this. We're now going to move on to actually getting a situation where services themselves want to start talking to each other. Sorry. In this case, we're going to start putting in the policy execution point, in other words, the gatekeeper between an application and the rest of the system. You can see in this particular case, we're using the policy execution point to secure the Orion context broker. And so far, when you've not got a user, or you're supplying it, as you saw when I supplied an invalid token, it just said nope. The policy execution point is basically that job, but for services. So we're hiding the 1026 port, and we're going to use 1027 instead. So you can access 1027 directly and say, okay, I want to get hold of something with the Orion Context Broker, and it will say, no, you haven't given me a user. If you've got a user in the header, which is obtained via the OAuth flow, which we showed earlier in the hour, it will make a request to Keyrock saying, is this a valid token? Are they allowed to do this sort of thing? Keyrock itself will say yes or no, and therefore you will be allowed access into there. So once again, we're using Keyrock for to adjudicate based on role-based access, and we're going to have some way of getting into the system itself. Still provisioning some devices, but we'll get in a second. So let's get into Postman. If I put in a invalid token or don't supply a token, I'm just going to get hold of all the entities in my system. I'll send something that says, no, that's not a valid token. Don't like you. Go away. If, however, I now log in, make sure I'm logged out first. Obviously, each time I'm starting, the token in question is probably dying anyway. So let's log in using the Bob's username and password. I've now got an access token. Let's see what happens if I put my access token in the header. As you can see, I can now access the full data from the Orion Context Broker because the PEP Proxy has said, I've received something. It's got a user. Does this user have access? Yes, they should. Okay, I'll let them through and come through. That's all that a PEP Proxy does. It's a protection method around the system. Now you can make this more flexible by increasing the level of difficulty within the authentication process. And this is where the final element we're going to cover today, called Authzforce, comes in. Authzforce is purely a policy decision point. As I said, Keyrock has got a basic policy decision point based on roles and HTTP verbs and what have you. But Authzforce is a much more flexible policy decision point, which is what's known as an XACML server. XACML is a standard for writing policies of any sort you like, which are written in XML, and they can be complex and they can be altered on the fly. Now, no one in their right mind would write these things by hand. You can generate them, but it means that you can have fine-grained access. If you take a very simple rule, and we'll show you one here, this rule on the right is saying in order to access the bell ring, in order to access the bell ring endpoint, and I send a post to it, I need to be in the security role. You can see it's very verbose. You could do this in a role-based Keyrock system very, very simply, but this means that you have the flexibility to do much more things. Each rule is one way you can get an effect. So you can get a permit, allow, if you cover all these things. The rule itself consists of a target, which is match this, match this, match this, but it can also have what's known as a condition, which is able to take more complex elements. So you could have a condition only between 9 o'clock and 5 o'clock, or you could have a condition which says I can access all these records if I created them, or if I am the owner of something else which creates them. So when it gets more complex, you need to pass more information. The way that XACML works is you have a series of rules, which if you can pass one of these, you'll get a thumbs up. And then overall, that becomes a policy. And the policy has got a hierarchy as to whether this is allowed or that's not allowed, or this is permitted, this is denied. And you evaluate the policy overall to see whether you can grant access. Beyond this, you can have a series of separate policies. So if you think of, say, a nightclub, if you want to get into a nightclub, you need to be rich, young, and good looking. Would mean that you could get in from any combination of these three elements, maybe except on the over 40s night, in which case being young obviously is no good, and therefore you would have a different set of rules. So you describe the set of rules in a standard here, so that overall we can evaluate what's going on. So let's see if we can get this up and running. Once again, I'll show you the actual diagram. Authzforce is now taking the role of the PDP as opposed to Keyrock. It takes a little bit of time to get everything to start up and running. Obviously, once again, we've got the usual information within our database, which we placed there beforehand. This is the system which is being set up at the moment. The difference here is that we are now using now set up to use Authzforce, and we have oh, no, sorry, that's the wrong one. Get the right one. Okay, so where are we? Keyrock. Keyrock is now using this IDM PDP at level advanced, which means that it is not capable of making a PDP decision itself. What it does is it says, okay, I have a user, I know you've got this user, they've got the following roles, but I'm going to delegate the authorization over to Authzforce. Authzforce will then is then on a different port, different location. As you can see, it's over here, and then when the PEP Proxy or whatever service gets hold of it, receives this information, it then needs to say, okay, pass the decision over to Authzforce to make the actual response. What Authzforce has is a huge XML file which covers all the rules in this XACML language, and it does the adjudication as necessary. So it's the one who is working out which rules you want to do. Once again, all this stuff can be generated from within Keyrock if you have advanced rules in your system. I'll try and show an quick example. If I go into here, I probably need to log out again. Escape. sign out and sign in again, because obviously the user I had beforehand won't have survived. I now go into my tutorial and I have managed my roles. Within the permission, that's a simple rule. And this one, you've also got the option to have advanced XACML rules, which we have set up in some cases. I can't remember which one off the top of my head actually are, but they do exist. So let's have a look at our thing in action. In order to make a request to Authzforce, you need to provide within your body all the information which is required. Make it a little bit bigger because XML is quite extensive. And you can see in this particular case, we are sending the subject this with the role, manager's role, within the application tutorial Docker site, and we're trying to get hold of the price change element. If we send that directly, it will return, again in XML, a permit response. Similarly, if we are putting in the wrong information, so we're saying, okay, I'm in the security role and I want to get to the price change endpoint, I can send that. And it will return deny. Now, all this you have seen already from the simple role-based application, but you'd only use Authzforce if you have more complex scenarios. One example I know of is where someone wanted to have permission to access values when they were in an abnormal state. In that case, you would say use something like a complex event processing to send an email to someone monitoring this thing to say it's now in an abnormal state, and then you could actually use Authzforce to check, allow people to access this if the value is above a certain level. That's the sort of thing which can't be done with basic role-based application, because obviously it will depend on the state of the system as to whether you're actually doing this sort of thing. So programmatically, what happens under the hood is that I need to, again, as Bob the manager, I need to get hold of my token. I have an access token. And when I use my token, it says, look, I know this guy, I know Bob. Bob is a manager, he's got the manager's role, and this is my application. And this is the other information I can give you about Bob. But within my authorization decision, I'm leaving a blank. I'm saying I'm not going to make a decision whether to permit or to deny Bob access to the system. Within I do, however, know that Authzforce, who you as a third-party system should know where it is able to adjudicate on this domain. A domain is a unique ID for setting up a series of policies. So having got that information, you can then, using that domain and passing in XML, say, okay, this is a manager, and we're trying to get hold of this endpoint. In this case, we're getting hold of the Orion Context Broker V2 entities endpoint, and we can send this information through and see, can I get hold of something? And the answer is, yes, you are allowed to do this. Now, this is programmatically held within the PEP Proxy to either allow or disallow people to get through the system. So if I now go back to my Where's the log gone? There we go. Okay, so we're now going to just log out as Bob. If we log in as Bob and then attempt to view the store, it's saying, no, I'm not. You're not in there yet. So I'm afraid I won't allow you to get into the system. If I now refresh, and if I was to go in a second time, it would say, yes, that's fine. You can come in and look at stuff. Just log out again. And if I log in as Eve, I can attempt to view the store, but it won't let me in for the simple reason that Eve has got has not got a role which is able to access the PEP proxy. So I'm able to stop people from coming into my system if I don't want them to come through. So that is a brief introduction to identity management and access control. Identity management is effectively a database, but it's a database which has got the ability to ensure that only the right individuals get access to resources. It's got things like usernames and passwords, so you can identify yourself, roles and permissions and what have you. One thing which I didn't mention is that obviously this is designed to be a generic security component. So if you want to hold more information about users, there is actually a website attribute which can be used as linked data. So you can get information on how to get hold of further information like their favorite cats or whatever is important for you. That would be held in a separate location because it's not actually something to do with whether they're allowed to do stuff or not. Access control is the selective restriction of access to resources and effectively can be subdivided into various different levels of security. Authentication is just saying, who are you? And usually if you have a system which is based on authentication, it means a user who can do everything on their own account and other people maybe just can view any account. You don't need to have anything more complex than that. Authorization is more complex than that, more restrictive than that, saying, is X allowed to do Y to Z? And the basic way of doing that is role-based authorization, RBAC, which, as you can see, you just have a verb, a resource, and a role who can do that or not do that for your permission. You can also get policy-based authorization, which, as we have seen, is more complex. When you are attempting to gain access, you pass through the policy execution point, which you can either have as a service like a policy execution point proxy, PEP proxy, or you can have it programmatically within the code. And then something else, usually a service such as Authzforce or Keyrock, will act as a policy decision point, a PDP. So that is you're allowed in or you're not allowed in. And the administration of these rules, you don't really want to set up by hand, obviously. So you use this using a policy administration point, which is the whole point about having a GUI. There are three FIWARE enablers which I've shown today. Keyrock is based on identity management and is either GUI or API based, and also is able to cover non-human actors such as PEP proxies and IT agents. And it is, again, implicitly multi-tenant because you need to pass a client ID and a secret in order to get into a system. And it is using the OAuth standard, which is a way of getting hold of the system. It doesn't, however, do complex authorization. It does authentication, but not complex authorization. The PEP proxy is effectively a gatekeeper, allowing you to, or more likely, denying you entry to places you're not supposed to go. And in order to identify these people, these users, not necessarily people, these actors, you are identified by placing a header in the resource. It can be used linked to either Keyrock or Authzforce. And if you were to use the PEP proxy with Authzforce to the fullest extent, you would need to extend the code to pass in additional information as requested to make sure you have appropriate authentication. As I said, if you want to get hold of all the records which I'm allowed and all my subordinates are allowed, I need to have more information prior to making that adjudication. Authzforce purely does the permit or deny using this XACML based rule set. And the difference here is that everything can be modified on the fly. It's able to retrieve a new set of rules at some point to start applying that straight ahead. It should be emphasized that there are other ways you can do security around FIWARE. There is the AppInf generic enabler, and there are other FIWARE compliant elements such as Keystone or telephonic steel skin. Furthermore, if your scenario requires it, you may wish to extend your security in other ways, say using IDSA security or whatever system is appropriate for you. It should be emphasized that you should always use the most appropriate tools for your use case. The philosophy with FIWARE is that basically we are an open system, we are open APIs, we are there to make it easy for you to transfer your data on there. Therefore, unless you make the effort to lock down your data, you are at risk of your security breach. So we are offering you a system. You must put this system around your data in order to do so. So that is the basic introduction to identity management and access control. And all that remains is for me to thank you for your time and hope that you had a good morning.